In this video, we want to talk about the 1, 2, 3 scheme, which is a short, easy to remember, and I think elegant solution of the Three Indistinguishable Dice Puzzle posed by Matt Parker on his YouTube channel, standupmaths. This method can be done without mental arithmetic, at least nothing more than multiplying 2 times 2. So let's take a look at the 1, 2, 3 scheme. The problem we're wanting to solve is that we have 3 dice that we can't tell apart, and we're wanting to use them to simulate a roll of 2 dice while preserving all relevant probabilities. So we'll solve this with 3 cases. Case number 1, we roll only 1 unique value. In that case, our simulation is the roll 3, 6. You can remember that this way. We've rolled 3 of a kind, so that's the 3, and there are exactly 6 ways of rolling 3 of a kind, right? Triple ones, triple twos, triple threes, etc. That takes care of the 6, so 3, 6. Case number 2, we roll 2 unique values. In that case, we simply ignore the repetition. So that gives us a roll of 4, 6 in this example. Case number 3, we have 3 unique values. In this case, we first put the dice in a certain order that I'll explain in a moment, and then we put value 1 off to the side and know that we're going to use value 1 in our 2 dice simulation, and we just need to figure out what other value we're going to use in this simulation. There are 4 values that come into question. We could combine it with itself, so value 1, we could combine it with value 2, we could combine it with value 3, or we could combine it with what I'm calling value 4, which is the average of values 2 and 3. So let's figure that out. The way we do that is we just multiply what I'm calling the neighbor distances. So the neighbor distance from 3 to 4 is 1. The neighbor distance from 4 to 6 is 2. So we multiply those. 1 times 2 is 2. So that means the value we have chosen is value 2. So we combine value 1 with value 2. Now the question that we need to answer is what sort of order do we need here? And that's what we're going to talk about now. I call this order minimal clockwise order. Let's say we had a roll of a 6 and a 5 and let's say a 1. Minimal clockwise order is something very easy. It just means the smallest span on the clock seen in a clockwise direction. So if I were to start at the 1 and take that as my first value, then I would have to go almost all the way around the clock until I got to my last value. If I started at the 6, for example, again, I would have to go almost all the way around the clock until I got to my last value. But if I start at the 5, you can see we get there pretty quick. So this would be my minimal clockwise order. So I have 5 and 6 and 1. So I just look at the neighbor distances. This one is 1, and this distance is also 1. That's important. The distance between 6 and 1 is only 1. Not 5, but 1, because we're measuring this on a clock. In other words, we're multiplying 1 times 1 and getting 1. So what we're doing here is we're combining value 1 with the thing that we just computed, which was 1, with itself. So that means we just rolled a double 5. Now the only one situation that we might want to consider is if we roll something like this. Let's say we rolled a 1 and a 3 and a 5. They are equidistant. So how are we going to get our minimal clockwise order? What we do in that case is we use ascending order, right? Because whichever one of these we were to start at, the span on the clock would be the same. So in that certain case, we just use ascending order, 1, 3, 5. Another way that that could happen was if we rolled a 2 and a 4 and a 6. Equidistant. So let's see what we would be figuring out if we had rolled a 2, 4, 6, since we're just using ascending order. So we know we're going to use value 1, and now we just need to figure out with what other value we're going to combine it with. So we have a neighbor distance here of 2, and here's a neighbor distance of 2. 2 times 2 is 4, so that means we're combining 2 with value 4. And value 4, as you'll remember, was just the average of these two, so 5. So in other words, we just rolled a 2, 5. So that is the 1, 2, 3 scheme.